So today we're going to see how to use Apache Spark in Microsoft Fabric. So I'm going through Microsoft Learn, going through step by step to understand. You know, I go through each of these statements as well so that we can understand it very clearly. Okay, how to use Apache Spark in Microsoft Fabric. Okay, so Apache Spark is just about the Apache Spark. Okay, first is an open source framework, okay, for large scale data processing and analytics. Okay. So big data and for implementing AI and ML, on top of the data bricks. So Apache Spark is the most important framework. It's a framework. Apache Spark is integrated into Microsoft Fabric to provide a big data platform. As I told you, it's a big data platform analytics and implement AI and ML also. Okay. So I mean, usually AI and ML is for predictive analysis, right? So you want to analyze the historical data and do some predictive analysis for the future. So obviously Microsoft Fabric, uh, you know, it's in a different session. What is all about the Microsoft Fabric, but yeah, it has the data science and machine learning integration as well. So when you look at the home page of the Microsoft Fabric, okay. But yeah, we are discussing about the Spark. Fabric Spark clusters provide a powerful in-memory distributed framework. So if you read this carefully, clusters, they provide a powerful in-memory distributed framework. In-memory, that is on RAM, distributed for at scale data processing, which is large data processing in Microsoft Fabric. Spark can be used together with other analytic services such as lakehouses, notebooks, and data pipelines. So this Spark, right, the Apache Spark can also be integrated with other services such as lakehouses, notebooks, and data pipelines. Okay. In this module, you explore how to use Spark with notebooks to ingest, process, and analyze data. So you can use Spark to ingest. That means ingest. Uh, ingest is something. It's like an ETL, extract, transform, and process the data and analyze the data in a Fabric lakehouse. Okay. So it can be integrated with lakehouses, notebooks, and data pipelines. So we have Spice Spark, which is integrated to Python, that can be used as part of data pipelines also, and in the notebooks as well to create some reports as well. Okay. So going to the next chapter or unit. So it's a distributed data processing framework. Distributed, that means distributed across multiple processes, enables large scale data analytics by coordinating work across multiple processing nodes in a cluster. So it has a cluster and multiple processing nodes. Okay, so multiple processing nodes, which is called as a Spark pool. So in Fabric, it's called as Spark pool. Put more simply, Spark uses divide and conquer approach to processing large volumes of data quickly by distributing the work across multiple computers. The process of distributing tasks and collating results is handled for you by Spark. I hope you understood this, right? It's a distributed processing framework. That means it's distributed across multiple processors for large data analytics by coordinating work across multiple nodes in a cluster. So it has a cluster, multiple nodes, and the multiple nodes is called as a Spark pool. Put more simply, Spark uses a divide and conquer approach. Divide to distributed multiple processors or computers, handled by Spark. Can run code in a different kind of range by languages as well. Java, Scala. Scala is a Java-based scripting language. Spark, R is Microsoft. Spark SQL Microsoft, and PySpark, specific Spark variant of Python. Spark variant of Python. In practice, most data engine analytic workflows are a combination of Spark and Spark. Mostly these two are used, and in Fabric also these two are used mostly. Okay, but it is also good to learn Java, Scala, Spark R also it is good to learn. So it can be used for other advantages. It consists of computer nodes that distribute data processing, as I told you, right? So data processing does. The general architecture is shown in the following. Computer nodes, compute nodes that distribute data processing. So it distributes into multiple processes. Architecture is shown 1, 2, okay. So one is a cluster and distributed in multiple nodes, and then process the data. Each process picks up the data, a batch of data, and then process it in a distributed framework. So that is how it conquers the data. Spark pool consists of two kinds of nodes. Okay, head node in contains distributed process to a driver program. Head node. First one is head node. Distributed, so a driver program. It has a driver program. The pool includes multiple workloads. Each executor process perform the execution. This contains executor process. So this is a driver process. This is the executor process. The Spark pool uses the distributor to access and process data in compatible data sources such as data lakehouse. Yeah. Process data which is stored in a data lakehouse. Again. Spark pools. What are Spark pools? Microsoft provides a starter pool in each workspace. Starter pool. Spark jobs to be started and run quickly with minimal setup and configuration. So each pool will have a Spark job to be started and run quickly with minimal setup. You can configure the startup pool to optimize the nodes it contains. Yeah, each pool has the head node in a Spark pool. So this is a pool. Head node, executor process, header, driver program. This is a driver program, this is an executor program, this is a pool. In this pool, one job will be there, Spark job. Starter pool to optimize the nodes contains in accordance specific workload needs or cost constraints. So you can configure this pool to optimize the nodes it contains in accordance to the specific workload. If the data is used, then optimize the memory of that starter pool to more value. Additionally, you can create custom Spark pools with specific node configurations that support your particular data. Custom Spark pools also you can create, not only the inbuilt but custom specific node configuration. So here if you see the node, the ability to customize Spark can be disabled by Fabric admin Fabric capacity level. Okay, can be disabled. For more information, see capacity and you can see that and go through that. You can manage settings for create new Spark for data engineering section. So here you see, right, data engineering section, Spark setting. You can create a starter pool here, number of nodes, how many you want. If you want to create a new pool, you can create a new pool and configure it. So specific configuration, node family, the type of virtual machines, node family, for in most cases memory optimized node provide memory optimized. So in order to process the data in an optimal way, you can use memory optimized nodes. Auto scale, whether or not to automate nodes as needed, if so initial maximum nodes to begin. So nodes can also be auto scale, can increase or decrease. Dynamically, whether or not to allocate execute processors. So there are execute processes, right, in the second step, whether dynamically you can allocate or increase the processes based on data volumes. If you create one or more Spark pools, you can set one of them as the default pool to be used if it's specific, not specified. Okay, one job. So if you create one or more Sparks, you can set one of them as a default pool to be used if specific pool is not specified. Default pool. Okay, starter pool. Okay. So for more information, we can go through that later. Runtimes and environments. So the Apache OpenSpark includes multiple versions of the Spark runtime, which determines the version of Apache Spark, Delta Lake, Python, and other codes that are installed. Open source. Spark is open source. Multiple versions of Spark runtime includes multiple versions, which determines the versions. So which version you need to use? Multiple versions of Spark runtime, multiple versions of Apache Spark, Delta Lake. Additionally, with a runtime, you can install and use a wide range of code libraries for common specified tasks. Since a great deal of Spark process is performed in the huge number of Python lines, shows that whether the task, whatever the task you need to perform, probably library to help. So Python, it's mostly used with Python. Python libraries will be there. So this is a bit tricky. Multiple versions of Spark runtime will be there. Okay. So for each version of the Spark runtime, there is a version of Spark, Apache Spark, Delta Lake, Python, and other software components. Delta Lake is, it's a lake, data lake where the tables are stored in Delta format. The two formats, Delta and Parquet. Since a great deal of Spark was using SpiceSpark, huge range of Python libraries. Just remember that. In some cases, organization may need to define multiple environments like Spark, multiple Spark runtimes to support a diverse range. Each environment specifies a specific runtime version, as I told you, right? Specific runtime, specific environment. Perform specific data engineering scientists consider which environment they use Spark pool for a particular task. Spark runtimes, Microsoft Fabric. Multiple Spark runtimes, Fabric, and will continue to add support for Azure release. So multiple runtimes are user specify the Spark that are used by default environment Spark. Okay, you can use the workspace settings. Environments in Microsoft, you can create custom environments enabled to use different runtimes, libraries, and configures different data processing options. So you see here different runtimes are there. Okay, Java, Scala, Python, and R. When creating an environment, specify the runtime, view the built-in libraries that are installed, install specific public libraries from the Python package indexes for specific data processing, install custom libraries, specify the Spark pool that the environment should use, specify Spark override default behavior, upload resource files available, resource files like data files. This is the default environment. Okay. Additional Spark configuration options, managing Spark pool environment are the primary reason to manage Spark processing. However, there are some additional options. Okay, optimization, native execution engine. Native execution is a vectorized processing that runs Spark operation directly on Lakehouse. Native can significantly use the native, improve the performance of large data sets in Parquet or data delta. I told you, right? Parquet or delta. To use the native execution, you can have an environment or within an individual notebook also you can do. To enable the native environment, set the following environment configure Spark native.enabled equal to Spark shuffle.manager equal to shuffle. To enable the native execution first, you can set this configure at the beginning of your code also like this. So native will make it more processing. High concurrency, when you run Spark session, you can optimize the efficiency of Spark resources by high concurrency mode to share Spark sessions across multiple concurrent users also. So high concurrency running at the same time. Because enable for notebook, multiple users can run in notebook that use the same Spark session also, while ensuring isolation of the code to avoid variables in one node being affected by code in other notebook, like locking of variables. Right? You can also enable high concurrency mode for Spark, enable similar efficiencies for concurrent non-interactive Spark script execution. So other scripts which are not interacting with this session also can be improved using the data engineering section of the workspace setting interface in Microsoft Fabric. Okay, automatic ML flow log. ML flow is an open source library that is used in data. I think you know ML flow, AutoML. Data center manage machine learning training and model deployment. Key capability of ML flow is the ability to log model training management operation. By default, Microsoft uses ML flow to implicitly log machine learning experiment activity without requiring the data explicit code to do so. You can disable from the workspace settings. So AutoML, it will try to do auto machine learning model deployment also. So ML, say AutoML is different, ML flow is different. AutoML is you have it in Power BI also, it will do auto machine learning. But ML flow, it also does machine learning training and model deployment also, part of the data science and machine learning. Key capability of ML flow, remember this carefully, is the most important point. Ability to log model training and management operation. Can log. By default, Microsoft Fabric uses ML flow to implicitly log machine learning experiment activity without requiring the data scientist to include explicit code. So auto logging. Disable this functionality also. Okay. So Spark administration. Administrators can manage Spark Fabric when restricting override Spark specificity. We can look into this.